All right, ladies and gentlemen, notes 2.2 is about adjusting numbers to write them in scientific notation. But before we can do any of that stuff, we need to just take a step back and really make sure that we understand how to find products and quotients when we're multiplying or dividing by factors of 10. Excuse me, not factors of 10, multiples of 10. So look at question number 1. Number 1 says 5.83 times 10, right? So you guys all know that if I multiply 5 times 10, I should get 50, right? So it should make sense to you that if I multiply 5.8 times 10, then I should get 58, right? And that if I multiply 5.83 times 10, I would end up getting 58.3. So really, when you're multiplying by 10, you're just moving the decimal place over. So this is going to be 58.3. Okay? All right, so in question number 2, if I were to take 489, if I were to multiply that by 10, I would end up getting 4,890, right? And then if I were to take 4,890 and multiply that by 10, I would get 48,900. So my answer is 48,900, okay? And then another way to think about this is if you were to multiply right here, see how this says 489? If you multiply 9 by 100, you get 900. So then if you were to multiply 89 times 100, you would get 8,900. And if you were to multiply 489 by 100, you'd get 48,900. Okay? Again, you can just move the decimal place over twice because there's 2 zeros in 100. So when I take 489 and I move the decimal place over 2 times, I end up getting my answer, 48,900. Okay? Last one, 102.4 times 1,000. Well, again, if I multiply 102.4 by 10, by 10, I end up getting 1,024, right? If I multiply 1,024 by another 10, I end up getting 10,240. Now, hopefully you know how many times you need to get to 1,000. You need 3 of them because there's 3 zeros here, right? So you have to multiply by 10 3 times. So if I were to take 10,240 and multiply that by 10, you get 102,400. Okay? So my answer to this is 102,400. All right? So now when I divide by 10, I'm going to go the other way. So see how this, if I were to take 3 and divide it by 10, it's really technically 3 over 10, which is 3/10. And the tenths place comes right after the decimal, so it's 0.3. Okay? But this is 3.89, so that means that this 3.89 right here, the 89 would follow along, so it's 0.389. So my answer is 0.389. 0.389. For 5, you have 93.5 out of 100. So my answer is going to be 93 hundredths, right? So here's my tenths place right here. Here's my hundredths place. So I have 93 hundredths and then the 5 tags along. So it's 0.935. Okay? And then lastly, we've got 2.395 or 935, excuse me, out of 1,000. Okay, so right here, this is 2 thousandths. So let's figure this out. Here's my tenths place, here's my hundredths place, here's my thousandths place, and I have 2 thousandths, just 2 thousandths. So I'll put a 2 right here, and then the 935 tags along, and then I put zeros to hold their places. So the answer to this is 0.002935. Okay. Now, for these ones, when you're dividing by 10 or 100 or 1,000 or any multiple of 10, you can just move over the decimal place however many zeros there are in the number. So this has 1 0, so I would just move it over once, and I would get 0.389. This has 2 zeros, so I move it over twice, I would get 0.935. This number right here has 3 zeros, so I'm going to move it over 1, 2, 3 times, and that's how you get the 0.002935. Okay, so we did 7 through 10 in class, so we'll skip those questions for right now and we will look at question number 11. The directions say to rewrite each of the numbers below so they are written in scientific notation, okay? So all I need to do is look at each one of my numbers. And number 11, this is not written in scientific notation because my coefficient here is not between 1 and 10. It's bigger than 10. It's too large. So I need to adjust it so that it's written in scientific notation. So what I'm going to do is I'm going to ignore this times 10 to the 8th power for right now. I'm going to cross it off. I don't want you to cross it off. Please don't cross it off. And because I'm going to erase this in a minute. So all I'm going to do is I'm going to rewrite 45.7 in scientific notation. Now remember, we said that since this is the ones place, this is the tens place. So it's being multiplied by 10 one time because this again is 4 tens. So it's 4 tens, but it's really 4.57 tens. And it's only being multiplied by 10 once. So this is 10 to the first power, okay? So all I'm going to do is I'm going to rewrite this number right here in scientific notation. So again, all I did was I rewrote 45.7 in scientific notation, okay? Now I'm going to just copy down this times 10 to the 8th power. So I'm going to write down times 10 to the 8th power. Now go back to the last unit. With our coefficients, we would just copy it down. But since this is multiplication, what should you do with your exponents? You should add them. So right here, I'm going to say it's 4.57 times 10 to the 9th power this time. Now my coefficient is between 1 and 10, so it works. Okay? Hopefully that makes sense to you. All right, and number 12. Same thing. I'm going to split it up. I have this piece right here, and I'm going to completely ignore this times 10 to the 5th power for right now. And I'm going to figure out what 0.085 is in scientific notation. Well, I know this is the 10ths place, and this is the 100ths place. So that means I end up getting, I'm going to do this on the side, 0.085. I end up getting 8.5 hundredths, right? Because this is the 100th spot and there's 8 of them. So I've got 8.5 hundredths. Since it's hundredths, it's times 1 over 10 to, or 1 over 100, right? Since it's hundredths. So then I end up getting 8.5 times 1 over 100 is just 10 squared. And then remember, you rewrite your number so that your exponent is not, your actual number is not a fraction, so that means my exponent has to be negative. So this number, when I rewrite it, becomes 8.5 times 10 to the negative 2nd power. Now I'm going to copy down this times 10 to the 5th power, okay? And then, again, it's multiplication, so I need to add my exponents. So I'm going to copy down my coefficient, my 8.5, and then when I add the exponents right here, I end up getting times 10 to the positive 3rd power because negative 2 plus 5 is 3. Okay? All right, number 13. You have this number right here is 5,821. All right? So this right here, since it's 5,000, it means I've got 5.821 thousandths, right? So I'm going to, again, do this on the side so you can kind of see where this comes from. So it becomes 5.821 times 1,000. Okay? But 1,000 just means that you're multiplying 10 by itself 3 times. 1,000 is 10 to the 3rd power. Okay? So this becomes 5.821 times 10 to the 3rd power. Then you have to copy down this times 10 to the negative 7th power. And then you end up getting, these will add together, copy your coefficient down, you get 5.821 times 10 to the negative 4th power. So this right here will be times 10 to the negative 4th power. Okay? And then number 14 is the last one that we are going to do. So in number 14, I need to take this point 0.000353, and I need to rewrite this for myself so I can make more sense of this. Well, I know this is the 10ths place, this is the 100ths place, this is the thousandths place, so this is the 10,000ths place. So I've got 3 10,000ths, 3.53 10,000ths really. So I've got 3.53 3.53 times 1 over 10,000. Well, I know that 1 over 10,000 really is 1 over 10 to the 4th power. So that means that this becomes 3.53 times 10 to the negative 4th power. So then I end up getting right here, let's block this off, 3.53 times 10 to the negative 4th power, but that's being multiplied by a new set of 10 to the negative 4th power. Now, don't let the fact that these exponents are the same confuse you, because it's just a coincidence that they ended up being the same. So now all I have to do is, again, copy down my coefficient, so I end up getting 3.53, and then, since this is multiplication, I have to add my exponents. Negative 4 plus negative 4 is negative 8. So I get 3.53 times 10 to the negative 8th power. Again, I know this might seem weird, but we will practice it until you feel more and more comfortable with this information. All right, have a good day.